We're going to talk about WebSocket perspectives and where WebSocket is going, the vision for the future. So how many people here have heard of WebSocket? Cool. Okay. How many people have programmed using WebSocket? Cool. Okay. So what we're going to talk about, I'll give real brief background since you guys, seems like most of the crowd here are very well aware of WebSocket. But let's find out what WebSocket really is and what it is not. Seems to be, might be some misunderstanding. And we'll talk about a layered approach to using WebSocket as opposed to using WebSocket directly. And talk a little bit about the cloud and where WebSocket can be used in the cloud. And that acronym XaaS is basically everything as a service, right? Which is obviously the direction we're going in. And then the last 15 minutes, we're going to see some really, really cool demos. Be surprised if you weren't here yesterday. So that's me. In case you want, in case Ann doesn't put the presentations up sooner, just hit me and I'll send you a copy of the presentation. And also, I think I have some of my colleagues, some of my homies from New York in the Java user group in the crowd. So we know why we're all here. You know, HTML5 is basically the new web, right? It's not HTML4+1. It's basically the new web. So we're getting new requirements for user interfaces. We all know about that. We're not building front ends that look like IRS tax forms anymore, right? That's old hat. That's kind of funny. We used that model for the past 15 years, right? But that's gone down the tubes, thankfully. And we're seeing an explosion of APIs, right? You go to Programmable Web or any one of these sites that catalog APIs, there's like thousands and thousands and thousands of APIs. So that is accelerating, and it will accelerate even further, not just with REST, but with JavaScript and other languages using real-time APIs. So the web's not about documents anymore. Of course, we know that's where it came from. And it's not even about like partial documents. We've tricked out the web over the past like 5 years, right? And not just doing documents, but doing micro documents, like sorted documents. But it's still, at its very essence, a document exchange, right? But where's the web really going? So the new web, and this is stuff you tell your boss, right? Your managers and your customers. The new web is basically a programmatic foundation for the new world, right? So it's not just a fancy way of doing CSS, right? Although most of my friends in New York do that. But, okay, we have HTTP as our protocol, right? And as you guys know, since you've done some WebSocket programming, WebSocket is an alternative to HTTP. Okay, because HTTP is designed for basically simple document transfer. I mean, at its essence, HTTP is like FTP. That's all it's doing, right? It's getting and putting documents. It might be micro documents. We're kind of tricking it out to do video and audio and things like that, but it's still an exchange of documents. And also, even though HTTP is bidirectional, you can only go one direction at a time. Right? And if you want to have a true bidirectional conversation, you have to open up two connections, right? One upstream, one downstream. If you really want to have true, well, not true, simulated full duplex. And also it's stateless because that's the way the web was designed back in 1988. Actually 1940s, but 1988 with Tim Berners-Lee. And it's stateless, which means, right, if it's stateless, you're sending state information, context information every time you do an HTTP message. So there's a large amount of context, in other words, metadata. So even though you're sending data, we all know you send metadata. And for things where you have, the quintessential example is a trading system, right, where there's a tiny bit of data, like 16 bytes, 8 bytes, 16 bytes, but then the metadata is like 1,000 bytes. And you're doing that for every single tick. So you're sending 1,000 bytes plus 8 or 16 bytes. So most of your bandwidth is a total waste, right? And actually, if you think about it, a lot of enterprises that are using REST and they constantly poll and they do these mega enterprises, most of the bandwidth of their enterprise is wasted. So we know that HTTP 2.0 is coming, and there's a lot of cool stuff with the speedy flavored HTTP. But really, at its core, the web wasn't really designed for event-based stuff, and some things really age really well. I mean, HTTP is great for static data. We know TCP, we know and love for the past 50 years, I guess, 50 plus years. But some things don't, right? And we know that what happens with technology, and also, not just technology, but this also happens in the real world with astronomy, with biology, where things get complicated, right? So here's comes a real cool invention, and then we use it for all kinds of new things, and then we decide to use it for something it wasn't designed for, even though some really cool functionality, but we use it to get this really cool functionality, but at its core it's complicated. Like the chaos index is very high. But we continue to do that until finally someone says, we got to stop and start over. And this not just happens with technology, it happens in all kinds in the real world. So that's what we're doing with WebSocket. So WebSocket is giving us real-time, and when we say real-time, we know we're all friends here. Real-time means event-driven, right? It doesn't mean we're not doing a nuclear reactor over the web, right? It's event-driven. And it's true full duplex. In other words, that way and this way, upstream and downstream on the same connection at the same time. And the IETF, and actually I'm lucky that I work with John Fallows, our CTO of Kaazing, who actually came up with the name WebSocket like 6+ years ago. And he worked on the IETF protocol 6 years ago, and as of 2011 December, it's now an official standard by the IETF. And also there's a W3C API for WebSocket in JavaScript, and I'm not quite sure, I think it's not a candidate proposal, but it's very close. So what we have with WebSocket, you could easily add event-based capability, and the reason why you can do that, because it's a persistent connection. So this is a different model than we're used to. It's a persistent connection. And it avoids all this metadata, right? Remember like the trading system application, and also for gaming too, where you're sending a little bit of data, a lot of metadata. So the metadata goes away because it's no longer HTTP, right? It's WebSocket. WebSocket and HTTP are peer protocols. WebSocket does not sit on top of HTTP. They're peer protocols both on top of TCP. And the cool thing about WebSocket, it shares the port with HTTP. And this is another one of John's ideas, because he wanted to get it to work with every single web server out there. It also means that you can have a WebSocket server that can handle web stuff, but in practice you're probably not going to do that. Right? You're probably going to have a dedicated web server for static things and a separate WebSocket server. As I mentioned, this is a standard. It's a protocol standard. It's very close. It's right now. It's a candidate. You're going to answer my own question. It's a candidate recommendation. So it's almost a standard. Candidate recommendation means if no one complains, a certain period of time it becomes a standard. And there's in case you haven't seen the URL, it's ws:// the rest, or WSS. As you would guess, WSS is the secure version. I was about to say SSL, you're not supposed to say SSL anymore, right? And it's text and binary. Originally it started off being text, but thankfully they added binary to do a lot of cool things. I guess it started off with text because we had just JavaScript as the language. I don't know why you use Microsoft software on Mac. Is it already frozen? Okay, I guess the arrow keys don't work. But why WebSocket? Okay, because in the HTML5 wave of stuff, right, it's just this massive combination of stuff. In our opinion, it's the most important API because it connects you with everything. You're on all the time. It's not you're on only when you make a request and response. You're on all the time. It's a persistent connection. And the way that the handshake works is that the client makes a request to the server, and as per HTTP 1.1, you can upgrade, right? You can request an upgrade, and if the server has it, says, okay, I have WebSocket, you're cool, and then HTTP drops out of the way. Obviously, if the server doesn't have HTTP, I think you get a 400, and you don't get WebSocket connection, you don't get upgraded. But if you do, HTTP at that point drops out of the way, and now you have a persistent connection to the back end, which means for event-based programming, which is the world that we live in, is event-based, can now live over the web through standard ports. This is a major milestone for all of us. And the way it works is that it's streamed data, but it's collected in frames. And the reason why I'm pointing this out, I mean, we can go into detail how the framing is. We're not talking about thousands of bytes like with HTTP. Okay, the framing, if you kind of look at the bottom, there's a little bit of opcode, say that is this, WebSocket data can come in sections. So this is why it gets a little tricky if you're going to program the WebSocket layer. You can get multiple frames be part of the same message, and it's up to you to coalesce that data. Like you can send hello world and HELLO space WOLD and like 11 WebSocket frames, and it's your job to coalesce that on both sides. So there's minimal overhead, right? If you kind of count the first few bytes, there's like anywhere from let's see, from 6 to 10 byte. Is that right? 6 to 10 byte overhead for WebSocket, as opposed to HTTP, which can have 1,000 byte overhead. So you can see the advantages. And in certain worlds, like in Java, I know a lot of people here are JavaScript based, but other languages now are following the standard, the W3C specified JavaScript API. Okay, right now there's a Java API, and there are other languages that have other APIs. So there is a standard, the JSR 356, which was passed. So now, and the reason why I point this out, which means app servers, which implement this JSR, implement the WebSocket standard. So over the near term, right now there's a few app servers that handle, like I think WebSphere, Glassfish, WebLogic. Over time, it's going to be part of the standard Java EE. So all app servers, which means everybody that uses an app server, which is a lot of people will use, have WebSocket capability. And also I found out recently that the last bullet, I know it's a little difficult to read, but this is Java on the server. So there's official Java API on the server side. There will be an API for the client side, for Java, not JavaScript, for Java. And that's coming. It was going to be in the latest version of Java, Java 8, which is going to be out in June. But it's going to be released later on, because Java SE, which is the client, and Java ME for the embedded world, so that's another wave. After HTML5, there's the M2M world that's following it. So we need a Java API, and other languages, of course, too. Java isn't the only language. We're all professionals here. Okay, now what WebSocket is not. So to do push from the server, asynchronously, we used AJAX, and we used reverse AJAX, aka Comet, right? You've heard of Comet, right? So it's not a new Comet, it's not a new AJAX. It's a protocol that sits next to HTTP. Okay? It's not a push mechanism. So when you guys probably understand this, but when we talk to customers, they see WebSocket, it's like, oh, this is push, right? Because no, push was 1995. This is a little different. It's a full duplex bidirectional mechanism. So it's not going to clients only. The client can go back, right? It's client server, but now over the web through standard ports. Okay? Very, very important. And it's not a messaging system. You can program at the WebSocket layer, right? We're all professionals here. You can program WebSocket layer. But don't think of it as a messaging mechanism. You can use it. It might work. But we get customers that say, like, I sent data and I only got like 90% of the data. What happened? Do you have a bug in your product? Well, no. You're programming at this layer, the low layer. So you have to do retransmits and acts and all kinds of stuff at the low level. It is not a messaging system. It doesn't really have messaging semantics. It's a transport mechanism that's up here to HTTP. So be aware of that. Okay, and it's not a replacement for HTTP either. okay? HTTP is not dead, right? It's fantastic for static data, especially because you can cache HTTP data, right? As we all know, it's very, very good at that. So HTTP will be around for decades. It's great for what it does. But for real time, it's not. So it seems like it's a no-brainer for most applications that do real time because we live in a real-time world, right? And let's take a look at the API. It's quite simple, and that's probably what, and also the socket API from 40 years ago is very simple, but it sort of belies its complexity. So you open up a socket, and there's a callback for opening up a socket. Excuse me. First, it's there's a constructor up there, new WebSocket, and there's a potential URL. And of course, you would never use that in production. You never use WS in production. You use WSS, right? And then you have a callback for open. The reason why you have a callback for open as opposed to just doing open, you're now doing a distributed open, and you have to wait for it to come back to say you have a connection. So if you haven't done WebSocket programming before, beginner mistake is that you open and you start sending data right away. You have to wait until you get the connection. That's why there's a callback. So that's why there's a little call out over there. Make sure you have a WebSocket before you send data over it. Okay, so then you have, there's receiving messages, there's of course close, there's sending messages. Okay, so it's a very, very simple API. We can all understand that. But it's a streams-based model. Most programmers cannot handle streams. Right? The average programmer sits in the middle of the Gaussian curve, right? And we have jobs to do. So we want a high-level API. I mean, this is like, we believe, at Kaazing, we believe history will repeat itself. That 40, 50 years ago, people were given sockets. Here's sockets, fantastic, go at it. People program at the socket layer, but what happens? After a while, it becomes a pain in the neck to manage, right? There's a lot of stuff you have to worry about. So APIs were built on top of socket, and we deal with RMI or JMS or AQP or XMPP, these higher level APIs. So we believe that's going to happen again. That most people will program up higher level. Because we want to give people old school functionality in HTML5, right? We're not going to worry about this low-level transport mechanism. There's a lot of stuff that you have to worry about. So where is the application protocol? I mean, how do you handle publish-subscribe mechanisms? How do you handle retries? How do you handle partials? Like, who's responsible for authentication, or authorization? There's a lot of stuff you have to worry about. If you're programming at that level, you have to worry about this stuff, right? And what if the client's not up? Right? Your user is on a train going through the mountains in Switzerland. What do you do? So there's a lot of stuff you have to worry about. But if you think about WebSocket like a TCP and build these other protocols that have these semantics on top of WebSocket, then you're golden, right? So you want APIs built on top of WebSocket. It's programmed a lot faster. You have the semantics, like for example, in a lot of the publish-subscribe models, they have transactional semantics. In other words, the user will definitely get my message. So if you're doing something that involves money, you want the user to get the message, or vice versa, right, from the client to send. You want transactional semantics. If you're programming with the WebSocket layer, you have to code that. And most people here do not want to code that. Right? So you want to rely on the higher level APIs. And just as an aside, like when you go in production, which is interesting, so with HTML5, you have all these cool functionality, new user experiences, all kinds of cool stuff. But you have to have these reliable applications, right? And you have to handle versioning, and you have to handle DMZs and HA, all the enterprisey stuff. So just as an FYI, when you program with all this, don't just like, I'm going to put a little server in EC2 and I'm going to have WebSocket and I'm done. There's a lot more to that. So I just want you guys to be aware of that. Like how do you handle bandwidth management with mobile devices? Right? Amazon's not going to do that for you, or some cloud vendor's not going to do it for you. So let me just take a brief step back and just talk about just JMS. I know, how many people have heard about JMS? Okay. So So I'll go 50-50. I'll go sort of fast, sort of slow. All right, so a little background on JMS. So JMS is a publish-subscribe model. Okay, and the reason why it's important, it's asynchronous messaging. Okay, most people are familiar with point-to-point, client-server. And many years ago, the enterprise found out that point-to-point stuff is brittle. And you'll find that out too, right? Especially services may be composite services. A service may call a service, may call another service. And this is very, very typical for the enterprise, which means going forward, it's going to be very, very typical for complex HTML5 applications. What happens if one of those services in the middle break, which happens a lot? If you have point-to-point that breaks, you're hosed. So messaging systems, I guess 20 years ago, like most major companies found out that messaging, where you put the messages on a bus, right, a logical bus, an enterprise service bus, ESB, it's a lot more resilient. And I believe the web world will find out that messaging is a lot better for services than point-to-point. It's just the resiliency is so much better. This is why ESBs were invented. Okay, so JMS is it's a Java-based pub/sub mechanism. It's publish, subscribe, so you register interest in an object. Typically it's a string, right? Sometimes called a topic. You register interest. Anybody that publishes data to that string gets that message. I mean, that's like the 25-cent description of pub/sub, but that's essentially what it is. And it has additional semantics like it's reliable, you can guarantee that the user got it, you can, if the user is not available, you can publish when the person comes back online. So there's a lot of cool stuff with JMS and other pub/sub systems too, AMQP, and there's a lot of JavaScript-based things. And the way you do that, the way you write code for in Java, it's very simple. There's some startup code that you create, and eventually you get to a send on the left-hand side. So the publisher says, hey, Frank, and then on the receiver side, or I should say the subscriber side, there's a little bit of upfront work, and then you have a callback. And I just have, my callback is just called on message, and it gets the string, hey, Frank, and I do stuff with it. That's real quick JMS. Now, if you had this JMS API in JavaScript, you do basically the same thing, right? So there's no mention of WebSocket, there's no mention of retries, there's no mention of transaction stuff. You automatically get this, right? You automatically get this. So again, some startup code, whether you're a producer or a consumer, in other words, if you're a sender or if you're a receiver, and you set the callback, the last thing is you set the listener to some method, some function that you want to call. So you send messages and you receive messages. It's very, very simple. So if you have JMS API in JavaScript, you're going to get the same type of semantics that you would get if you're inside the firewall. So there's a lot of advantages. And there's a lot of companies that provide this. I mean, our company provides it. You can get this at ActiveMQ and some other sources. I think I have a slide that has sources on this presentation. So with the high-level APIs, not just for JMS, but for AMQP, for XMPP, for all kinds of stuff, you know, FTP, et cetera, it's way easier to do WebSocket programming. You can port applications quicker to the web, right? You now can do event-based APIs, right? I was just talking to a gentleman outside here with Eventbrite, which I use, a very, very successful ticketing system that I use for the Java user group and the HTML5 user group in New York. Very, very good. But one issue that I found is that you have somebody registering. Let's say you have a capacity of 100 people, and as they register, the number goes up, right? 1, 2, 3, 4, 5. But you have to refresh the page. So with WebSocket, this can be real time. It could be like a bar that moves as you're watching it, right? So that would be kind of a cool enhancement. So you get all this other good stuff when you program at a higher level, right? And it gives you the opportunity to focus on the application, which is always a good thing, right? And there's many sources for WebSocket and for JMS and other APIs. And obviously, our company Kaazing provides a lot of these things. You could download off our website for development. Of course, Nodejs is a fantastic open source tool for that. We all know about Nodejs and providing that behavior in older browsers. So again, if Aaron doesn't give you the presentation, just ping me. I'll send you a copy of this so you have all the sources. So it's not just a small set of people doing this. The whole world. I mean, we live in an event-based world. This is how you simulate, in other words, write programs, which is what that is, over the web. And there's a lot of interesting examples. We're going to see some live examples in a few minutes, but you can go out there and just search for some cool things. There's many gaming sites that use WebSocket, collaborative drawing applications. The application down the lower left is where people are using their smartphones to create a song in real time. So if there were 6 people and we're all staring at this giant screen, it may have been in New York, but you're writing a song and you can see your notes in the track and live as you're doing it. And then when the last person gets done, it plays a song. So they're composing it in real time. And someone has MIDI over WebSocket, so there's another API on top of WebSocket. And I always like the Google Gem. If anyone seen the Google Gem? Very cool application where you can jam over the web. You have with your musical buddies using WebSocket. Very cool. So what's next for a WebSocket? Okay, we know that it's mobile first. You program for mobile first, and because a mobile app is easy to port to desktop, it's not true the other way around. Right? So make sure you tell your manager this. So you develop a desktop and you port to mobile, it's a pain in the neck. The other way is much easier, right? There's a reason why I say mobile first. And you're connected to a series of clouds. Now what's interesting about this? PowerPoint still doesn't work. Come on. Okay. So this is a marketer's view of the cloud, right? And we have all seen this, the 3 layers of the cloud. Software as a service, platform, and infrastructure. I always like software as a service, like all this stuff is software. You can't say applications as a service, right? How do you pronounce AAAS? I guess you can pronounce it. But what's more accurate? Okay, more accurate, it's a multi-layered stack, and you have the compute network storage at the bottom, and I think recently telecoms is down there now too as a infrastructure substrate, and of course applications at the top. Now the middle is where everything gets interesting, right? The so-called PaaS, the PaaS layer, platform as a service. That layer is just getting bigger and bigger and bigger because it's getting very stratified. There's higher level frameworks, there's low level frameworks, right? And all these infrastructure players are moving into that space because there's more margin. They can make more money with PaaS, right, as opposed to infrastructure. So they move into the platform. Is like Amazon. Are they an infrastructure player or are they a platform player? Most people say they're an infrastructure player. But they have, electric beanstalk, and they have messaging, and they have other stuff, right? So are they an infrastructure? Are they a low-level PaaS or a high-level? So you notice there are different levels of the strata. It's not just 3. I mean, obviously a marketing person came up with that last slide, right? Just to make it simple for people to grok it, right? There's really many layers. But what's interesting is that PaaS layer. And the reason why it's interesting is because that's where all the APIs are, right? That's where all the APIs are. And again, I took some of this data from Programmable Web, but there are other directory services for APIs. And I just looked at them this morning. There's over 9,000 public APIs, and there's like 8,000 mashups. And a mashup is just a composite service, right? And most of them are REST-based. And they're all public, and of course the enterprise APIs that you don't hear about are probably just as numerous. You just don't hear about that because they're private. I mean, we've had enterprise APIs for like 20 years over private line. But over time, more and more APIs will be event-based. People are starting to think, I have WebSocket, I have publish, subscribe. I can offer a real-time API through port 80, or port 443 for real, to my customers. Okay? This is completely different than it was before. I can offer a real-time API. It may go to JavaScript, or it may go to Python, or it may go to Java, or it may go to .NET. But you can now offer this stuff over a standard port in an event-based, quote-unquote, real-time mechanism. And as one of my colleagues said, this is like, we have no SQL, this is like no REST. Because with REST is synchronous, request response. It's RPC. And you can simulate real time, right, by polling, right? So you poll, like you say, you poll every 10 seconds. Well, it's not really real time. Let's poll every 5 seconds. Let's poll every 4 seconds. Let's poll every second. Let's poll every half second. So what happens if you decrease that time? The machine starts saying, like, please stop doing that. So it's really not a good solution. You can do it, but it's just not the best thing. And you can think about how many enterprises are doing that. Every enterprise is doing that, which means you're sending metadata over the wire needlessly. So here's the growth of APIs. Obviously, it's pretty obvious where it's going. This is the PaaS layer. This is why the PaaS layer is very, very important to people. Most of the APIs people will be using will be coming from outside of the enterprise, which is a shock to a lot of people. And as we move on in time, we're seeing that everything is becoming a service. So that's why I use the term XaaS. I have no idea how I can pronounce it. So I'm not a marketing person, so I could Zaz, I guess. Shaz? Shaz. Shaz. Okay, Shaz. So with Shaz, you can notice that there are some services that, okay, there's database as a service, storage as a service. That seems that we've been doing that for a while with Amazon and friends. But there are now other things. You can now do enterprise messaging as a service. You can have WAN optimization, identity, security, testing. All kinds of stuff are now appearing as services. And the client is now connecting to multiple clouds. You cannot do this with REST. Right? Going forward, you just can't. You can try to do it with REST, but you can't do it. It's an event-based world. And even going further, you can take it where you can take ESBs, since you now have WebSocket, you can connect to ESBs. One could be in one cloud, one could be in another cloud. So when you send messages, you could send them over the web without a private line, without a dedicated circuit. Which, if anyone believes you had a dedicated circuit, I should land in Florida, I can tell you there was no such thing as a dedicated circuit. It was only shared. But I digress. So there's a lot of cool things that you can do with what's called an integrated PaaS, where you're connecting ESBs together, which a lot of companies are already doing, by the way. And then going a little bit further out, we have the combination of HTTP 2.0, which is speedy flavored. The Google stuff is now being folded into HTTP 2.0. So if you have, essentially what Speedy does, it shares a TCP connection. So you have multiple HTTP connections that share one connection, which is obviously a good thing. You have that, plus you have WebSocket. You have some powerful network transports to play around with. And also WebSocket is going to continue to evolve. There are extensions like multiplexing and compression. I mean, imagine multiplexing a WebSocket connection. That's pretty powerful stuff, and that's really close. Doing WebSocket, not just not just TCP to WebSocket, but you can do the inverse, which means you can proxy a client-server application without each side knowing it's being over the web, which is pretty cool. And there's a lot of other cool stuff that we can talk about, but I think the best way to talk about some of the cool stuff is, let me turn over to my colleague Peter, who will show you some really cool demos.
Hello everyone. My job at Kaazing is set to be probably the most exciting, or probably one of the most exciting jobs, is to bring life to some of our machines, some of our computers, and show the power of what you can do with a WebSocket. So what we decided to do today is take some risks and do some live demos. Some of them are going to be demos that we have never ever shown before, simply because we finished them only a day or two ago. So the first one will require a browser. Is this a browser here? The demo that I'm showing here is out there on the public internet, and our screen resolution is a little low, so I'll try to do some scrolling here. What you see here is a foreign exchange application. I'll scroll down a little bit, and you see data come in to this web client. The rate at which the data is coming in is, maybe I need to resize this window a little
Click the
bit.
green plus, it will fill the size of the screen. There
Thank
you
you. The rate at which the data is coming in is about 10 messages per second. And we can bump up this data rate, and suddenly the data will go up to 50 messages per second. We can bump it up further to 100 messages per second, and then it will be really fast. To build an application like this in the past, we needed technologies like Java applet or Flash application or a thick client application. And now, with the power of executing JavaScript inside the browser, we can build these apps, and having this very low latency connectivity in the browser, we can do these without any plugins, any installs, simply by doing HTML5. Many of our customers are in the financial services space, and they are building trading platforms on our product. Security is absolutely critical to them. Supporting all the browsers that are out there is absolutely critical to them. Most solutions that you find out there support all the most recent browsers, have some fallback techniques for older browsers. But when you are in the business of serving your banking customers, most of the time you cannot afford to lose 10% or 5% of your customers. So you have to support browsers all the way back to IE6. You have to support browsers on mobile devices, and that's exactly what you see here. So this demo is live on demo.kaazing.com. If you go there, you can try it out from home, and it works from anywhere in the world. This is the first use case. So the first use case is you have a lot of data on your servers, and you want to get this data out to your clients as fast as you can with some additional constraints. So in the financial services business, there's this notion of fairness, where the latency or the time difference between the client that receives the message first and the client that receives the message last cannot be more than, I believe, 200 milliseconds. So there are all sorts of regulations around it. And with the help of these extra layers that Frank was talking about, JMS specifically, you can achieve these requirements. A lot of data on the server, you want to push it out to a large number of users real time. This is the first one. The second one is just as interesting. So what you see here is a WebGL Race Car. This car is rendered in Chrome without any problems, with all the hardware acceleration. It's pretty impressive what you can render. I mean, if you just look at the reflections there, the race car has two mirrors on the two sides. When the car and the camera are positioned properly, you can see objects reflected in that mirror. It's pretty impressive what you can do. And as you would imagine, you can take your keyboard and you can start driving the car around on using your keyboard. Now, this is powerful by itself. So if you think of building applications with HTML5, these are the kinds of things that you can count on. But what is even nicer than that is that now on my phone, I'm going to open a browser. And on the bottom of the screen, there is an ID that I will enter. And again, this is on the public internet. So if you take a note of the URL up there, or if you just go to demo.kaazing.com, then you can give that a try. So on my phone, on the browser, I connect it to the URL, and I start tilting the phone. And simply by tilting the phone left and right, back and forth, I'm driving the car around. And best of all, my phone is not even on Wi-Fi. My phone is on LTE. So what is happening here is that the desktop or this laptop here is connected to a WebSocket server and is waiting for the messages to come in. You may remember when Frank mentioned that this is an event-driven world. Basically, we are listening on the messages. We are listening for the messages to come in, and when we get some messages, we act upon that. And that's exactly what's going on. And then my phone is connected to the same WebSocket server. So the two devices are connected, and there is the pseudo peer-to-peer relationship between the two with the help of the WebSocket server. Very much like with HTTP, you cannot have a connection between two clients, between two browsers, but both of them can connect to the same server, and then you can send messages to each other. Now, if you use this, or if you want to achieve this just with plain WebSocket APIs, it can be a little cumbersome, but when you are using pub/sub techniques, when you're using something like a JMS that Frank described, then it can be very, very easy. The way it works is that you have a notion of a channel or a topic that is a kind of a named abstraction where the phone is sending the messages, publishing the messages as I'm tilting it, and the browser on my laptop is subscribed to that same topic and is receiving the messages. And it knows that when the events are happening. And it's so fast that actually the server we are connecting to is on the East Coast. And when I do these kinds of demos from other continents, connecting to the servers on East Coast, EC2 servers, they work just fine as well. Again, this is a demo that's online, and you can try it out. So doing these pseudo peer-to-peer kind of experiences, it's a very, very neat one. Sometimes when I look at this car, I feel like it comes off the canvas. And so we wanted to do something interesting, basically take this car off the canvas. And if this was not a scary enough thing to do, I'm going to make it even scarier. So I will need some help. I asked our friend Steve to help us, so I'm going to call him over Skype, see if he's around. Am I doing the right thing here? Let's try a video call with Steve. You guys may not hear him, but hopefully you will see him. Let's try to call him again. Okay, maybe I'll start explaining, and maybe Steve can call us in a moment. So I mentioned that the car looks so real at times that it feels like it comes off the canvas. So we wanted to build something that really comes off the canvas. So here's this car that is a simple, cheap RC car that we bought at Toys R Us. And what we wanted to show is how the gap between the web and the real world can be bridged. So what we did was we took a Raspberry Pi and we put it here on the plateau of the truck. What the Raspberry Pi is, if you haven't seen or played with it, it's a $25, $35 little computer that has USB ports, has an HDMI out, can take an SD card, has 512 meg of RAM, and it can run pretty much any code. It can run Linux on it. So we put this little device here, and we wanted to show that not only can we set up messaging between web browsers as clients, but we can also send messages to non-browser clients. And when you do this in a peer-to-peer fashion again, then this can be very nice and powerful. The reason why I wanted to conference in Steve is because Steve is not here in the room. I wanted to show that we can do things with this car simply by being on the internet somewhere out there at an undisclosed location. Okay, so Steve is not there, so I'll try to do the trick from here. So here's the car, and I take my phone, and again using my browser. I'm connecting.
There you
Oops,
go.
Steve is here.
Let it go to voicemail.
Hello, Steve. Say hi to Steve. Very cool. So, Steve, we are here with a truck. Let me show you. And can you show us your phone? Can you show us the phone, please? So Steve has a phone with a browser on it. It's not very easy to see, but it's a remote control for the car. So, Steve, can you please flip the lights on the truck? There's small LED lights. Very cool. Steve is, by the way, at an undisclosed location. Some of you may recognize the lights. He's downstairs at the Kaazing booth. Excellent, Steve. Now, can we do some more scary things here? Can you drive the car forward? Very cool. Can you steer left and right? Very nice. Now I'll put it down. Can you drive it a little bit around? We don't have a lot of room here. Just drive it blindly. Forward. Can you drive it a little forward? And now back. Very cool. So what is happening here? Thank you, Steve. This was awesome. So what's happening here? Again, we have two WebSocket-enabled clients. One is a phone running a web browser out of the box that can connect to the WebSocket server. And we have Java code running on top of Linux on the Raspberry Pi that connects to the same WebSocket server. With Kaazing and with other implementations as well, WebSocket is not restricted to JavaScript and HTML5 clients. You can build other clients. So here we use Java, but you can use .NET and Flash and other client technologies as well. And we use the same messaging technique, JMS, that we use for the race car, for the tilt versus the remote control. The Raspberry Pi has generic purpose input-output pins that control the motors, forward, backward, left, right, and the lights as well. We published all the source on GitHub, and if you want to check out how this all was built and want to see videos, all you need to do is go to blog.kaazing.com, and we have a very detailed article that describes how it was built. Here is the very famous car, some videos of it, all the building blocks that we used, what car we bought, and how you can build this. So hopefully this gave you an idea how far WebSocket can be stretched, and I'm sure you can probably stretch it even further out. The idea is that by having this always-on, bidirectional connectivity, you can build very different kinds of applications. You can build way faster, way more responsive kinds of applications. And if you think of the racer demo, or if you think of this guy, these are not dynamically generated web pages. These are not websites. These are applications that use the web as an infrastructure to communicate back and forth. Okay? Frank, do we have some closing slides?
No, actually, we have time for some questions. Does anybody have any questions? Yes.
Sure. So I also have a little Eventdriven thing that I'm working on, where I'm streaming data using WebSockets from a microcontroller to a web service. And I was curious to try and get more throughput if I was able to stream data over TCP instead of WebSockets to a back-end service. But then I started running into issues with framing, or if you want to specify like the length of the bytes. And then I realized it's like, well, what the hell? Like,
Let me make a guess. Let me make a guess here. You are not using Kaazing. Yeah, so you do run into many of those troubles, especially when you're at the low-level WebSocket layer, and that's what Frank was alluding to. And when you move a layer up, where many of these problems are taken care of for you, and you can if you can afford to do that, and in most of the applications you can, then you're way better off because you don't have the headache otherwise. And I forgot to mention, no, never mind, yes.
How does WebSockets and/or Kaazing solution compare to like Thrift or Protobuf? Thrift or Protobuf?
I'm not familiar with
There
them.
are RPC protocols you can use, your language.
You can use that on top of WebSocket. We have customers that use Protobuf on top of WebSocket, especially some of the Wall Street customers. Yes.
Is there an overlap in functionality between WebRTC and WebSocket?
We are talking to some people about WebRTC, so we're not a replacement for WebRTC, but WebRTC, which is the peer-to-peer real-time video, it needs signaling capability to tell the other browser, hey, someone's calling you. That's what we're doing. So you can just put them together. As a matter of fact, most our WebRTC people can use WebSocket together to get the full benefit.
What sort of latency gains have you seen as a result? Like, how much faster, or what's the latency?
What's expected latency?
Yeah, sure.
Every network's different. We sit on top of the network, so whatever network can give us, that's what we get. But we're very close to the network speed.
Let me give you an example. We did a benchmark test not too long ago. We had one Dell server, one blade. Actually, it was a set of servers connecting to 1 million users per client concurrently, sending 10 messages per second to them, and the latency that the infrastructure was adding was about 3.5 milliseconds. Another way to approach it is that with HTTP, the overhead is 1,000, 1,500 bytes with every message. With WebSocket, it's only a couple of bytes. So you can expect like a 1% of the overhead compared to HTTP.
Kaazing doesn't add any to that overhead.
To what
The 2 to 6 or 10 bytes overhead. Kaazing doesn't add any.
It depends. If you're using higher level, richer business protocols, then that protocol obviously does add overhead. It gives you higher level abstractions as well.
back there?
Yeah. What is the implications for the on load balancing and server overheads?
That's a very, very good question. Most load balancers are geared towards HTTP, and now we're entering a new world. So load balancers over time have to change, and some of them are changing. We thought about this years ago. So actually our product handles that, load balancing, but all the load balancer companies are recognizing that WebSocket is different than HTTP. So existing load balancers may have problems with that, so they may become a bottleneck. But so a lot of them, like Cisco and company and the F5s of the world, they're all looking at WebSocket and coming up with WebSocket capable load balancers.
What does it use for the fallback mechanism on IE? Like Socket uses some fallback mechanism for IE.
So we don't fall back. So we use WebSocket as our foundation. We don't fall back to HTTP. That means HTTP is your foundation. We emulate the WebSocket protocol on legacy browsers. So on IE6, you'll get WebSocket protocol, but we emulate it for you. So how we do it is transparent to you as a developer.
Are there any battery life challenges for mobile devices? Because it's like an always-on kind of thing, right?
Oh yeah. So in terms of battery life, we actually did a study where instead of being on off, actually having a consistent connection is actually better. If you want that information, I can get that information for you.
Okay.
We can exchange business cards. I get that information. Yes, John.
It seems so logical to be used for Facebook or for Gmail or for YouTube. I'm kind of surprised that why is it not used currently? Is there any disadvantages of using WebSocket in this case?
I think all those companies are looking at WebSocket.
So they are using or they are just looking at it?
You'll have to ask that. But I mean, if you follow the forums and you follow them, those engineers are talking about WebSocket. This is clear. For real-time stuff, this is the direction you're going.
I have one more question. Like, if you look at a Yahoo Finance, like a few years back, right? They were refreshing the page and all. Like, what were they doing like 5-6 years back when we don't have the WebSocket?
They were doing probably Comet, reverse agent. They were polling.
Polling.
This is all software, right? You can do anything you want in software. But where's your pain threshold? That's the key question to answer, right? So you can poll, and if you poll, the CPU is going to go up, right? So you just add more machines. So if you're a big company, oh, I need 1,000 more machines. I get more people, get 1,000 more machines. So we feel that that's not a scalable solution. You can do it, and a lot of people have been doing it. Now you can do it with far fewer machines.
Okay, so I think we'll take one more question, and if you have more questions, we'll be around, and also downstairs we have a booth. We are happy to show the car or any of the other demos. We have highly interactive presentation tools. You can play Pong using your phone as a remote control. There's a lot of things that you can do, and a bunch of demos down there. There is a book that came out recently that talks about some of the concepts that Frank described. We have some down as well at the booth, so you're welcome to take a look at those. So the last question here.
Outside of financial services, what's the most exciting practical real-world application of WebSocket today?
Telemetry. We've had some big car, I can't mention the name, big car sports. Happening very close to race, circular, that sends their telemetry data. If the drivers or the gas bill going down to the website, so on the website you can see actual information. They're slowing down, speeding up, with their gas bill in real time.
Thank you very much. Thanks for coming.